Let's practice converting between mass, moles, molecules, and atoms. Remember that we can convert grams into moles by using the molar mass, which is in units of grams per mole. We can convert moles into molecules or atoms or particles using Avogadro's number. And if we have molecules, we can break that down into smaller pieces like atoms. Number 1, how many moles are in 0.0265 grams of magnesium chloride? To convert from grams to moles, we're going to need the molecular weight of magnesium chloride. To do that, we will use the periodic table. So let's find out the mass of a magnesium, according to the periodic table, is 24.30 grams per mole. And the mass of a chlorine atom is 35.45 grams per mole. And our formula, magnesium chloride, has 2 chlorine atoms. So adding up the mass of each element in magnesium chloride will give us 95.20 grams per mole for magnesium chloride. So converting, we have 0.0265 grams times, we want grams on the bottom and moles on the top. So 1 mole over 95.20 grams of magnesium chloride. Notice that our grams of magnesium chloride will cancel out. And after doing the math, we get 2.78 times 10 to the minus 4 moles of magnesium chloride. Number 2, what is the mass of 8.15 times 10 to the 19 molecules of carbon dioxide? In order to convert molecules into grams, we first have to convert to moles. So let's start by using Avogadro's number. There are 6.022 times 10 to the 23rd molecules of carbon dioxide in 1 mole of carbon dioxide. And our molecules of CO2 would cancel out. And if we stopped here, we would have moles of CO2. We want to continue because we're looking for the mass of CO2. So to get the grams of CO2, we will need to know what the mass of 1 mole of CO2 is, which we can get from the periodic table. So we know that carbon has a mass of 12 grams per mole, and oxygen has a mass of 16 grams per mole, which we have 2 of. And if we add, we get 44 grams per mole for carbon dioxide. Plugging in the molar mass of carbon dioxide and canceling out our moles leaves us with grams. And we end up with 5.95 times 10 to the minus 3 grams of carbon dioxide. Finally, how many atoms of oxygen are present in 619 grams of C12H22O11, which, by the way, is sucrose or table sugar? In order to convert from grams to atoms of oxygen, we have to first convert to moles, then to molecules, and then into atoms. So let's start with our 619 grams of C12H22O11. And in order to convert that into moles, we're going to need the molecular weight, which we can find using the periodic table. So let's come over here. We know carbon is 12 grams per mole, and we have 12 of those. Hydrogen is 1 gram per mole. We have 22 atoms of hydrogen. And oxygen is 16 grams per mole. We have 11. So the molecular weight of C12H22O11 is 342 grams per mole. And if we cancel, we have converted to moles. Next, we will want to convert the moles into molecules using Avogadro's number. So 1 mole on the bottom. So the moles cancel. And Avogadro's number, 6.022 times 10 to the 23rd molecules of sugar in 1 mole of sugar. We cancel that out, and we have converted to molecules of C12H22O11. But we want to go one step further. We're looking for how many atoms of oxygen that is. And so in 1 molecule of C12H22O11, there are 11 atoms of oxygen. And that just comes from the formula. Cancel out molecules, and we're left with atoms of oxygen. We get 1.20 times 10 to the 25th atoms of oxygen.